Hey guys, here's the last example that we were going to do in class. We kind of ran a little short on time. So let me help you get started with it, and then you could always pause the video and try it on your own and then get little hints as you go. Alright, so we have 20 feet of wire to be used to form a square and a circle. And they want to know how should we cut the wire, if at all, so that the total area is maxed or minimized. Okay, so when it says if at all, that means technically you could not cut the wire and only make one shape to answer one of these questions. Alright, so I know some people always say, but it says you have to make a square and a circle, but I don't think that's what it means when it asks you for both. If they're giving you this option, then that is an option. So that means you have to check what if you use all 20 feet for the just the circle, or all 20 feet for just the square. Does that give you a maximum or a minimum, if at all? Okay, so 20 feet of wire, 20 feet of wire. That's 20 feet. And some of it's being used for a circle potentially, and some of it's being used for a square. So let's just say, what if we cut it here? Okay, and let's say we cut off X number of feet here, and that leaves us with 20 minus X number of feet here. And one of these is going to be used for a circle, one is going to be used for a square. So let's say this is being used for the square, not drawn to scale, and let's say this is being used for the circle. Alright, again, pause it anytime if maybe I've already given too much away, but pause it anytime you're ready and try it on your own, and only come back when you need the next step. Alright, so if this is 20 minus X, and this is supposed to make up the entire box, the entire square, so then this would be 20 minus X over 4, right? 20 minus X over 4, that's what all these would be. And if this is a circle, then that would be the circumference. The circumference would be just X. So the circumference is X, which of course is 2 pi r. And they're telling us to maximize or minimize the area. So I need the area of this square and the area of this circle. So the area of the square, of course, that's no big deal. That's just 20 minus X over 4 squared, right, times itself. The area of the circle is going to be pi r squared. But r is X over 2 pi, right? Because we know the circumference is 2 pi r, and that's supposed to be whatever I used for X. Again, this could have been switched. It doesn't really matter. You'll still get the same thing. But the radius is going to be X over 2 pi, which will go right here. So the area of my circle is pi times X over 2 pi squared. So then my total area, right, the total area of my square and my circle is going to be this thing plus this thing. That's my total area, and that's what I need to try to find maximums and minimums for. Alright, so now what I would say is, as far as how to solve this using calculus, I understand you could just graph this and literally find like the max and min, but you're going to need to at least do a little bit with with the calculus. So what I would say is, you could probably take this derivative by hand and then at least graph the derivative if you had to, or do an n deriv if you need to get those critical values. Or you could just do the whole thing by hand. It's not the worst thing in the world, but it is a little tedious with the way it's set up here. So what I'll do is I'll at least get the derivative by hand. Let's do that. So my derivative, I'm going to do a power rule, chain rule. So this is going to be 2, 20 minus X over 4 to the first, times negative 1, times negative 1/4. Can I fix that? There we go. Right, because this is really 5 minus 1/4 X, right? So negative 1/4 plus 2 pi X over 2 pi to the first times the derivative of what's inside, which is 1 over 2 pi. And there's my first derivative. So this can get cleaned up a little bit. Negative 1/4 times 2 is negative 1/2. I'll leave this alone for a second. Plus, how convenient, 2 pi times 1 over 2 pi. I'm left with X over 2 pi. Clean that up one more time. This is going to be negative 20 minus X over 8 plus X over 2 pi, and that's my derivative. Okay, I could get a common denominator and solve this by hand, but let's go ahead and use our calculator at this point. Okay, so I'm going to graph that. That's going to be negative 20 minus X divided by 8 plus x over 2 pi. And my window, I know for sure I can only go from 0 to 20, okay, which was already there because I did this before. And I'll do a zoom fit out of convenience. And this is my derivative now, right? This is my derivative. So my derivative is telling me that I have negative value, then positive value. So at this point, I know I'm going to have a minimum, right? My first derivative goes from negative to positive at this point. So I'm going to find that point. So it's somewhere between, what was that, like 8 and 10? 8 and 10, guess about here. So x equals 8.798 is my critical value. Okay, so that's going to be a minimum again because it went from, my first derivative went from negative to positive. So this is going to give me a minimum. So when it says, so I basically solved for b first just because that's what came up on the calculator. So when x is 8.798, so when x is around 8.798, that's my circle. So my circle will use, the wire should be cut, 8.798 for the circle. And whatever's left over, that's going to be what, 11.202 for the square. Minimizes area. What about maximum area? Okay, right? From here it looks like, you know, your first derivative is negative and then it's positive and then it just stays positive forever. So it looks like if I use x equals 20, I'm going to have the most possible value for my area. Right? Let's graph the original just to confirm that. Watch this. Let's graph the original equation, which is here. Right? So 20 minus x divided by 4 squared plus pi x over 2 pi squared. And let's do a zoom fit for that as well. So I just graphed the original, hopefully. So check that out. So I have a minimum here for sure. I'm guessing that's 8.798, right? So left bound, right bound, guess. Again, that's not the calculus. That's just, well, technically is calculus, but that's not what they want you to do. They want to at least see the derivative. So there's your minimum. And look at the max. The max is all the way up here when x is 20. Right? When x is 0, if you use the whole thing for the square, you're only here. But if you use the whole thing for the circle, you're way up here. So if you want your maximum, all 20 feet for the circle is the max. That's how you would conclude that. Okay? So let's just walk through it again real quick. 20 feet of wire being cut. You have so much for one part, so much for the other part. Find your formulas, whatever it is. Sometimes it's circumference, sometimes it's area, whatever it's going to be. And then just set up your equation. And if it looks like it's going to be too tedious to do by hand, let your calculator do the work. But at least do some of the calculus by hand in case, just for the practice, if really for nothing else. Okay. Again, we could always set up our number lines for confirmation, but I think based on the calculator, we've already confirmed it. All right. Hopefully that helps. Again, let me know if you have any questions, and I will talk to you guys later.